Good day everyone, I am Prottay and today I will be presenting our work titled Flux PMU, a maker's guide of a do-it-yourself Phasor measurement unit. This work has been completed in Alset Lab of Rensselaer Polytechnic Institute in collaboration with Dr. David Laverty from Queen's University, Belfast. We'll begin with a short introduction. We all know that the Phasor measurement units or Synchrophasor technology in general has changed the landscape of power system research and power system operation in the recent years. The improvements has been drastic in terms of protection, monitoring, reliability, to name a few. But the concern that we're trying to address in this research is we do not have enough open source, user-friendly, good, reliable opportunities to tinker with or to learn the applications of Phasor measurement units. So to solve this problem, we built upon the legacy of the OpenPMU, which already exists, and reported our own implementation that focuses on safety, cost effectiveness, user friendliness, and we are also providing and reporting extensive documentation for the software and hardware implementation parts. So in terms of hardware implementation, we made our own custom Flux PMU board. This PCB board was made in Eagle PCB software and it is shown in the right hand side of this slide. The additional components that were introduced inside this PCB board were a PIC microcontroller, which enables the NMIA data transfer from the GPS to the computer, a data acquisition unit which was made by National Instruments, which enables the analog voltage reading by the computer, and a GPS receiver which receives the GPS signals and sends them to the PIC microcontroller for further processing. Additionally, the PIC microcontroller also produces the 60 Hz pulse strength, which is important to frequency estimation algorithm. Now, how does this hardware fit in the overall organization? The blue box in this slide represents the hardware part. The red part represents the software part. The gray part represents the networking and the green part represents the timing. This slide also shows how the timestamp, the GPS timestamp, is shared across the different sections of this organization. The red part, the software part, focuses on signal conditioning and data acquisition, and it's implemented in National Instruments LabVIEW graphical programming language. And this, the voltage measurement using this graphical programming language is also shown in the bottom right corner. It can be seen that when applied with a 2 volt peak to peak, 2 volt, not peak to peak, 4 volt peak to peak voltage waveform, purely sinusoid with 60 Hz frequency, our Phasor measurement unit reliably measures the voltage. Now, where does this implementation fits in the bigger picture? As I have already mentioned, whatever we have implemented is logged and recorded in the repository. We have already reported in the paper and in this presentation. We'd also like to have this opportunity to let you know that our implementation was very cost effective. The entire hardware, software, the individual circuit components, wiring, everything costed in total of $750, which is much less than the industry grade PMUs. And the use of graphical interface makes it very easy for the undergraduate students or newcoming industry personnel for training. Thank you for listening and have a good day.